Algebra 2, we're in lesson 11.9, probability of independent events and dependent events. Let's read together here. Two events are independent. Independent events, if the outcome of one event does not affect the outcome of the other. If you toss a coin 2 times, those are independent events. The second toss is not affected by the first toss. So what we're going to see is this. If two events are independent, the probability of A and B occurring would simply be the probability of A multiplied to the probability of event B. What you're going to see is for independent events, the word and is generally going to mean multiply. Let's take a look and see how this can come together. A spinner has 8 equally sized sections. 2 are gray, 6 are blue. The spinner is spun twice. What's the probability that the first spin lands on gray and then the second spin lands on blue? So we want the probability of gray, and then the second one would be blue. Well, no matter what happens for the first spin, we're going to assume that it has no bearing, no effect on the second spin. So it's simply going to be the probability of spinning a gray, multiply that to the probability of spinning a blue. So gray, we've got 2 successes out of 8 possible outcomes. So that's 2 out of 8. And we're going to multiply that to the blue, which would be 6 out of 8. Now, of course, right now you could use your calculator to immediately get some assistance. We can just as well reduce these fractions by hand. But please do realize that we need to reduce. If we don't reduce and simplify, Alex, our computer program, is going to mark you incorrect. You don't want that to happen. So 2 over 8 times 6 over 8, you can see that would be 3 out of 16. So you can see that's your final answer in simplest form. Take a look at example 2. It says, of people who fished at Clearwater Park today, 36 had a fishing license, 4 did not. So we've got Clearwater, and that means we had 36 had a license, 4 did not have a license. That also means when you add them together, you're going to get 40 total. Remember, when you're dealing with probability, you're going to need to know a success all over a total. When we look at the mountain view, 25 had a license, 25 did not, we're being told here. That means we'd have 50 total. So suppose that one fisher from each park is chosen at random. What's the probability that the fisher chosen from Clearwater did not have a license, and the fisher chosen from Mountain View did have a license? So we want the Clearwater to not have a license, and we want the probability for the Mountain View that they do. So these are independent events. These are separate parks. No matter what the probability is for Clearwater, it's not going to influence what's happening at Mountain View, and vice versa. Well, at Clearwater, we've got 40 total, but we are considering measuring the not, so that would be 4. That's 4 out of 40. That's the probability that somebody from Clearwater would not have a license. 4 successes out of 40 total. For the Mountain View, that's 25 all over 50. So again, you could use your calculator if you'd like. you could say alpha y equals and get in your 4 out of 40, which by the way is 1/10. We know that. And 25 over 50, that's actually going to be 1/2. So it's not all that difficult. And you can see we'd get 1/20. So that's your probability of having the first park, the Fisher person, not having a license. The second park would have the Fisher person being a licensee. So let's go to page 2. Two events are dependent if the outcome of one event affects the outcome of the other. For example, if you pick a card from a deck and do not replace it, not replacing seems to be the big theme of the day. Once you pick another card, the first event affected the second. The deck got smaller. You'd only have 51 cards, and you would have lost whatever first card was selected. So if two events are dependent, the probability of A and B is the probability of A multiplied to the probability of B, given that A already happened. Again, we're still going to multiply. We're still going to multiply, but you're going to see things are going to change. So let's read example 3 here. A radio disc jockey has 7 songs on the upcoming playlist. 2 are rock songs, 3 are reggae. So we've got 2 rock, we've got 3 reggae, we've got 2 country songs. And there are 7 total. So the disc jockey randomly chooses the first song to play, and then she randomly chooses a second song. What's the probability of first getting a reggae, and then the second is going to be a rock? So we'd say reggae and rock. Well, we're going to say first it's the probability of getting the reggae, which, by the way, you can see that there are 3 right there. That's 3 out of a total of 7. But now we want the probability of getting a rock song, given that a reggae was selected. So that's the big difference. Once a reggae was selected, you don't have 3 reggae songs anymore. Now you only have 2. You have 2 rock songs still. You still have 2 country songs. But now you'll have 6 total. So you can see there were 2 changes if you're not replacing it. You can see really what's happened is your total has dropped. And because you selected 1 reggae song and you're not going to replace it, you have 1 less reggae song to deal with. So what's the probability of selecting a rock song now? Well, you still have 2 rock songs to choose from, but now instead of having 7 total, you used 1 up. Now you only have 6. So right here you can go ahead and get help with the calculator, of course. You can say, well, we'll have 3 out of 7 times 2 over 6. And real quick comment here, you can see it's going to be 1 out of 7. Actually, you could have seen it was 1 out of 7 real early. 3 times 2 is a 6, and that would have canceled right there. It's a nice, cool way to reduce without having to type it into your calculator. Let's do our last one. A university class is 24 students. 8 are nursing students, 3 business majors, and 13 psychology majors. So again, they're telling us we've got 24 total. The professor is planning to select 2 students for a demonstration. The first student will be selected at random, and the second will be selected at random from the remaining students. So that student is not replaced. So what is the probability that the first student is a nursing major? And then the second student would be a business major. Well, the nursing, you can see, you've got 8 successes out of 24 students. But once you select that nursing student, you'd only have 7 nursing students left. You'd still have 3 business students. You'd still have 13 psychology students. By the way, your total will have dropped. You'll only have 23 total because that one student is now gone. Well, now you want to find the probability you'll select a business student, so that will be 3 out of 23. Well, again, you can go ahead and work this out with your calculator. You can also reduce by hand. We'll talk about reducing by hand real quickly. That you can do some really nice cancellation with fractions. But you can see right here, we'll go 3 all over 23. You can see we should get 1 over 23. Well, how could we do this without having to type it into the calculator? Well, 8 goes into 24 3 times. So we would have had a 1 over 3, and then our 3's would have canceled out here. So whether you type it in with the calculator or cancel it out, you get the same thing. Now, by the way, please watch out. This is where we can get into trouble. Here it says round your final answer to 3 decimal places. Look, you can always go to math and go to decimal here. Really, we have to write 0.043 for our final answer. Always paying attention to what is being asked. You can see the previous question, they did want us to answer as a fraction. But pay attention, sometimes you'll have to go to a decimal.